Okay, grade 8. This is chapter 4.2 from your fractions, decimals, and percents unit. We're working on page 142, which is from section 4.2, on calculating mentally percents of numbers as well as calculating percents of numbers using a calculator. So we have questions 3 through 10, which take place on page 142 to 143. And we're going to start with question 3. So question 3A says, what is 300% of 2,000? Now, it says calculate mentally. So what you have to do here is you would have to say, well, I know that 100% is 2,000. And therefore, if I triple it or multiply it by 3, I will get 300%. And therefore, 300% must be 6,000. So the logic that goes into A is if 100% is 2,000, then 300% would be 3 times that amount, or 6,000. Question B says, what is 1.25% of 60? So what we really want to do is the first thing mentally, because if we're solving this mentally, is we're going to find what is 1% of 60. And 1%, what we do is we take our decimal. If we move it one spot, we get 10%. If we get 2 spots, we get 1%. So there 1% of 60 would be 0.60 or 1 point. I'm going to think of it as money. I'm going to always think about things as money if I can. So 1% of $60, if it was, would be 60 cents. Now the next part, a quarter percent would actually be whatever 1% is, taking that amount of money and dividing it by 4. So 1% is 60 cents. So a quarter of a percent would be a quarter of 60 cents, which would be half is 30 cents, and half of that is 15 cents. So therefore, when we combine them, we'd have 1.25% is equal to the combining of those two, which would be 75 or 0.75. And the third part, question C, says what is 0.1% of 40? And just as a side note here, another way I could have written this question is a 10th percent of 40, right? These are the same questions. And the reason why we want to have it either way, for mental math, it doesn't matter. We know that the rule is 10% is move the decimal 1 spot, 1% is move it 2 spots, and for a 10th of a percent, we move it 3 spots. And just as a point of reference, if it was 100th of a percent, it would be 4 spots, and so on and so forth if we wanted to. We only focus on these top 3 ones. We don't get into really hundredths of a percent mentally, but just as a point of reference, if you did need to figure it out, you would just move the decimal 4 spots. So if I take my decimal here in 40 and move it once, that's 10%, 1%. I have to move it another spot, but in order for it to go there, I have to put a 0 down, and therefore my answer would be 0.040, or just, since that other 0 is insignificant, 4 hundredths. So if I was asking this as a question, I'll erase this part up here. If I was saying, what's a 10th of a percent of $40? The answer would be, it's 4 cents, right? 10% would be $4, 1% would be 40 cents, and a 10th of a percent would be 4 cents. All right, moving along to question 4. Again, it's mental math. So A says, what is 20% of 60? And the interesting thing is this isn't even a grade 8 question, it's a grade 7 question. 10% is move the decimal 1 spot, so 10% is $6, or 6. So therefore, if I double it, I would get 20%, and therefore 20% of 60, or $60, or 60, whatever you want to think of, is either $12 or just the number 12. Doesn't have to be dollars. Question B asks for 250% of 400. Now for this one, we're going to, obviously, we're dealing with something more than 100% of it. So the first thing we're going to do is find out what is 100%. That's the easiest question I could possibly ask you. What is 50%? Well, 50% would be half of that, so it'd be 200. And how many hundredths percents would there be? There'd have to be another one. So I'll add another 100% here. Add them together, you get 250% is the sum of those, which is 1,000. So 250% of 400 would be 1,000. Question C, the last one in our mental math, says 10.5% of 100. So our first one is to find out 10%. Move the decimal one spot for 10% to get 10. 1% is move it two spots to get 1. And 0.5% would be half of, obviously, 1%, which would be 0.5. So the two I need to combine are simply 10% plus that 0.5%, which would mean 10.5% of 100 is 10.5. Question number 5. Now we get into using a calculator. So the first question in 5A says, what's 2/5% of 325? Now before we get into this question, I want to make sure we understand what this looks like. So I'm going to take my insert a table. I'm going to make it 10 by 10, and I'm going to reduce that down a little bit and bring it down here. So 2/5%. Now remember, 2/5, I gotta write this down. 2/5% is not the same thing as 2/5. Because if I was to shade in 2/5 of this with my highlighter, 2/5 would be roughly, I think, that much. That's 1/5. That's 2/5. That would be 2/5, which is actually 40% of something. But that's not what this question says. This question says 2/5 of a percent, which means that right there, which I circled, is 1%. So if I was to grab my highlighter and shade in, roughly that much of it, and then magnify it over here to show you what it looks like. There's that square magnified, cut into fifths. The number of fifths that are shaded in are 2 of them, so where's 1/5? I better shade with a bigger one there. 1/5, 2/5. That's what 2/5% would look like, not 40% of something, but rather not even half of a percent, less than half of percent of something, okay? So mentally, that's the first thing you have to understand. And once you have that kind of in your head and you understand what it is, then the rest kind of makes sense. So I'll erase this thing here. Okay, so how do we do this? Well, the first thing you have to do is realize that 2/5%, when we have it in a fraction and it's a percent, it doesn't work well because we know the percents are out of 100. And if I put a fraction in the numerator of a percent out of 100, it looks like a stacked sandwich wall tower thing that doesn't make any sense at all. So we can't utilize fractions when we're dealing with changing them to decimals. So 2/5 is equal to 4/10. Therefore, 2/5% and 4/10 are going to be the same amount. And 4/10 as a decimal is this. So therefore, all three of these, I'll put a percent sign there, 2/5%, 4/10%, 4/10% are all the same thing. But our starting point for this question is going to be this. This is where we're going to start from, okay? So we're going to change the fractional percent to a decimal percent, and now we're going to go into realizing that percents are out of 100. So 4/10% would be this, which is equivalent to, since we can't have decimals in numerators, I have to figure out what do I multiply decimal 4 by to get the decimal gone. I only have to move it one spot, which means multiplying it by 10 is sufficient. And that now becomes 4/1000ths, which if I think of my tenths, my hundredths, my thousandths, 4/1000ths will look like that as a decimal, okay? So going back to my original question, 2/5% of 325, since 2/5% is the same thing as 4/1000ths, and the word of is really, in mathematical terms, multiplication. If I multiply this out, I will calculate what 2/5 of a percent is. So I grab my calculator, 0.004, that's 4/10 or 2/5% of 325, and the answer is 1.3. Question number 5B So that's 15.25% of 950. So 15.25%, again, we have this fraction part here. So 15.25%, since we all know a quarter is decimal 25, these two questions are going to be the same, and this is a better starting point. Since percentages are out of 100, this percent as a fraction would be 15.25 out of 100. I'm not allowed to have decimals in numerators. This time, instead of moving it one spot, I actually have to move it two spots to get rid of it. So every time you multiply by 10, you move it one spot. So here I'm going to have to multiply it by 100 to create an equivalent fraction that does not have a decimal in the numerator. And 100 times 10 is 1,000. 100 times 100 is 10,000. So the equivalent fraction of this would be 15.25 10,000ths. Think about my place value. Tenths, hundredths, thousandths, 10,000ths. 15.25 10,000ths looks like that is a decimal. And therefore, this question, 15.25% of 950 is that equation, or that multiplication question. Take my calculator. 15.25% of 950 is approximately $144.88 because you got to round up. So $144.88, and I got to put my approximately equal symbol there because I did round it. Question 5C says 175% of 125.50. So again, just using logic, since mentally we know that 100% is the money itself, and 175% is going to be definitely more than $125. If I was estimating, I'd probably guess around $200, but I wouldn't know. So now I have to figure out, okay, since percentages are out of 100, 175% would be 175 out of 100, which is an improper fraction. But as a mixed fraction, or as a mixed fraction, is 1 and 75 hundredths, which is 1 and 75 hundredths. So 175% written as a decimal is 1 decimal 75, or 1 and 75 hundredths. So therefore, 1.75 multiplied by your 125.50 will be your answer. Grab your calculator. Multiplying by 1 would be 100%. Tacking on an additional decimal 75 would be the additional 75% of that, of 125.50. Again, we have an answer we have to round here, so it's $219.63. So approximately $219.63. Question 6A, 5/8%. So 5/8% of 520. Again, this number here, 5/8%, is not the same thing as 5/8. Okay? But we do know that 5/8% is slightly greater than 0.5%. Since 4/8% would be 0.5%, then 5/8% would be slightly more than 0.5% of something. That's the logic you can kind of use to estimate if you needed to. But we're not estimating, we're calculating. So 5/8%. 5/8 is a decimal, so if I take 5 and divide it by 8, I get 0.625. So since 5/8 and 0.625 are the same number, then this percent and this percent are the same thing. Okay? Percents are out of 100, so 0.625 out of 100 would be what that 5/8% would be as a fraction. This time I have to move the decimal not once, not twice, but 3 times to get rid of it, which means I have to multiply it by 1,000 this time in order to get rid of that decimal. So decimal 625 multiplied by 1,000 is 625. 100 multiplied by 1,000 is 100,000. I don't think I've ever had to use a 100,000ths position, but let's look. So tenths, hundredths, thousandths, 10,000ths, 100,000ths position. So 625 has to end in the 100,000ths position. So I got to put a couple zeros there. And therefore, as a decimal, that is 5/8%. All right. So therefore, I take that and I multiply it by my 520. Grab my calculator. 5/8% as a decimal is 625 hundred thousandths of 520. The answer is exactly 3.25. Question B, 75 2/5% of 200. 75 2/5 is the same thing as 75 4/10%, which is the same thing as 75 4/10%. These are all the same thing. So now that I know that, 75.4% is 75.4 out of 100. I need to get the decimal gone. I only have to multiply it by 10 to get 754 out of 1,000, which written as a decimal is tenths, hundredths, thousandths of 200. 75 4/10% of 200 is 150.8. And since we're dealing with dollars, it would be $150.80 if we were dealing with money. And finally, question C, 250% of 7650 in money. So percents, there's no decimals or fractions here, so 250% would be 250 over 100, which is 2 50 hundredths, which is a decimal is 2 50 hundredths, but that 0 is not really necessary. So 250% is really 2.5 times $76.50. Grab your calculator. 2.5 or 250% of 76.50 is $191.25. Okay? Easy peasy, lemon squeezy. Question 7 says 200 tickets are being sold for a school draw. What is your chance of winning with one ticket? So again, this is a part to whole ratio. There are 200 tickets being sold. Of them, you have one. So the question is, what percent is one chance out of 200? Since this is a fraction, we have two routes we can go. We can make it into an equivalent fraction out of 100, because we know that percents are amounts out of 100. So I can divide this by 2 and divide this by 2. And I have this temporary bad fraction, 0.5 out of 100. But I'm only using that to then realize that it's 0.5% or 0.5% chance, right? 0.5 out of 100 would be 0.5% chance. Alternatively, you could go 1 divided by 200. Take your calculator and say, what is 1 out of 200? Sorry, that's divided by. As a decimal, the answer is 0.005. So there's your chance as a decimal. And what is this as a fraction? Well, it's 5 thousandths, which is equal to 0.5 out of 100, which is equal to 0.5%. Two different ways to think about it. Obviously, the easier way is probably just writing it as an equivalent fraction of 100, but both methods do indeed work. The second part to that question says, how many tickets would you need to sell? So how many tickets would you need to sell out of 200 to give yourself a 2.5% chance? So there's a whole bunch of different ways to solve it. I set it up as a what? What is this method called? We did this. It's set up as a proportion, right? So if I say how many tickets out of 200 is equivalent to 2.5 out of 100 or 2.5%, there's two different ways we could do it. We could figure out, I multiplied this by 2 to get this. So therefore, to keep it equivalent, I would multiply this by 2, and I would know I would have to sell how many tickets out of 200? 5. That's one way to do it. Another way to do it is to use this cross multiplication method in proportional reasoning. Multiply across this way and this way. So 100x equals 500. Right? Divide both sides by the coefficient. And you get x equals 5 as well. Different ways you could set it. I like setting up any percent question like this as a proportion. X is the unknown amount, and set it up using proportional reasoning. Question 8. The original price of a jacket was $84. So the original price was $84. The store manager discounted it by 25.5%. So the first thing we have to do is figure out, well, what is 25.5% of $84? That's the first thing. This is the discount. We can do it mentally. I think this works its way well to be mentally. 25% is half of half, so half would be 42. Half of that is $21. 1% is 84 cents because I moved the decimal twice to get 1% for 84 cents. Half of that would be 42 cents. So a half percent is 42 cents. And therefore the total discount would be the sum of those two, which is $21.42. Okay? So that is how much it was reduced. On your test, what I love to do is say how much is the cost of the coat after the discount. So there's one further step that you would have to do here. You'd have to take your $84 coat and subtract the discount. To get the sale price, which would be $62.58. So you take your discount, subtract it from the cost of the coat to get the actual price of the coat. But this is the actual answer, is what is the discount? My further extension would be, given that you know the discount, how much is the coat going to cost you? Right? Question 9. The highest point in Canada is Mount Logan, which is in the Yukon Territories. Mount Logan is 159% of the highest point in Alberta, Mount Columbia, which is 3,747 meters. 3,747 meters. What is the elevation? So really what we're looking for is 159% of 3,047 meters. All right. Now we can do this mentally. Do 100%, do 50%, do 5%, do 1% times 4, or do 100%, do 50%, do 10%, minus 1%. But I'm going to use a calculator for this one. 159% is this, which is this, which is this. So therefore, to get my answer, 159%, 159%, use my calculator, 159% of 3747 is 5957.73 meters. I think it says rounded to the nearest. No, it doesn't say rounded at all. But that would be how many meters tall Mount Logan is. And your final question, when water freezes, its volume increases by about 10%. How much does the volume of a 750 mil amount of water increase when it freezes? So what is 10% of 750? It increases by 75 milliliters. That's A. What is the volume of ice created? Well, you take your original 750 and add that. The amount of ice that would be in that container would be 850 mils.